All right, I'm going to be going over Chapter 7, Practice Test B. The probability of an event that is 4 out of 25, so that's going to be 16%. And when you're at 16%, when I ask you what the probability is, it's either going to be impossible, certain, unlikely, likely, or equally as unlikely and likely. And this one is 16%, so the way you would answer this one is you would say it is unlikely. Number 2, you randomly draw a marble from a bag, record its color, then replace it. You draw a red marble 11 out of 20 times. 11 out of 20 is a red marble. What is the experimental probability that the next marble will be red? Well, so far, 11 divided by 20 is 0.55, so that's 55%. So if it happened 55% of the time, the experimental probability of the next one being red is 55%. There are 7 yellow marbles and 10 blue marbles in a bag. You randomly choose one of the marbles. What is the probability of choosing a yellow marble? So the favorable outcomes would be 7, and the total is the 7 marble yellow and the 10 blue, so that's 17. So when you do 7 divided by 17, you get 0.41176447. And I'm going to just have you round this to the nearest percent. So we go like that, 41.1 or 0.2%, but we're just going to run it to the nearest percent, which is about 41% chance that you'll grab a yellow marble. Number 4, use the table to predict the number of times you will spin a 6 once you spin the spinner 100 times. Well, let's see how many times we originally spun it. So 7 plus 11 plus 11 plus 6 plus 8 plus 7, that gives me 50 spins. Now, I know that I'm wanting a 6, so I want this one here. In 50 times, I did 7. 50 times, I did 7 spins. So in 100 times, I'm going to do 14. All right. Number 5. You choose between yellow, purple, green, blue, orange wallpaper and orange, blue, red, green, yellow carpet. Okay, so we got wallpaper and carpet. Oops. And we want to find the total number of possible outcomes when you select one wallpaper and one carpet. Well, we see that yellow, 1, 2, 3, 4, 5. There's 5 different choices with the wallpaper, and there is 5 possible outcomes for the carpet. And the way you can put those all together is you multiply the 2 events. So 5 times 5 equals 25. 25 different ways that you can put one of those colors of wallpaper with one of the colors of carpet. Number 6, you roll a 6-sided cube, okay, and then you flip a coin. What is the probability of rolling a number greater than 5 and flipping tails? So greater than 5, we know that this is going to be out of 6. A cube has 6 sides. So greater than 5 would just be 1, because you can only get 6. And then flipping a tails, the total possible outcomes would be heads or tails, so that's 2. Flipping a tail is 1, so 1 out of 2. And then we're going to multiply these together. We get 1/12. And so the probability of flipping or getting a number greater than 5 and flipping a tails is 1/12. Now you could keep that as a fraction, or you could make it into a decimal, or a percent, which is 8.3% chance of doing that. Number 7, you choose 2 different side items. That's a very important thing. 2 different side items on a menu at random. Out of 9 side items on the menu, there are 3 are vegetables. The first side item you choose is a vegetable. What's the probability the second is a vegetable? So the first time, there's 3 vegetables out of 9 side items. So that would be the chance of getting it a vegetable the first time. But it says that we got one on the first time. Now, what is the possibility of getting a second vegetable? Now we don't have 3 anymore because we want a different one. Now we only have 2 vegetables, and one of the vegetables is gone because we can't do the same one. So now we go from 9 side items to 8. And so the probability of getting the second one as a vegetable is 2 out of 8. I could reduce that to 1/4, and then I could reduce or convert that to a percent, and I'm going to get a 25% chance that the second side item I choose is a vegetable. All right, you have a toy vending machine contains football helmets and sticky hands. There's 36 items in the machine. Winning a football helmet has 5 times as many favorable outcomes as winning sticky hands. How many each item is in the machine? Well, we know there's 36 total in the machine. So I'm going to make X equals the football helmets, and X equals the sticky hands. Now it says that to get winning a football helmet has 5 times as many favorable outcomes. So 5 times X, which is the sticky hands, is going to get me the football. So now all I have to do is do 5x plus x, and that's going to get me the number of items in the machine, which we know the items is 36. It tells us that. So 5x plus x is 6x equals 36. I divide that by 6, divide that by 6, x equals 6. So now I go over here and I change that to 6. There are 6 sticky hands, and then 5 times likely to get a football helmet is 6 times 5, which is 30. So there are 30 football helmets and 6 sticky hands. And that makes sense because we know that in the machine, if we add these 2 together, we're going to get 36 total items. Number 9, you roll a number cube and record an even number 9 times in a row. As the number of times you roll an even number increases, so you keep doing it and keep rolling an even number, what happens to the theoretical probability that you roll an even number? Right here is the key. Theoretical. Does the theoretical percentage ever change? Now, experimental probability definitely changes because you're doing it different numbers of times and you're not sure what you're going to get. But I think of a coin. The theoretical probability of flipping a heads is 1 out of 2. Now, no matter if I flip it 1,000 times or 1,000,000 times, the theoretical probability is always going to be 1 out of 2. So what happens to the theoretical probability? Doesn't change or stays the same. Number 10. The tiles shown are placed in a bag. You randomly select one of the tiles and return it to the bag. You randomly select another tile. What is the probability that the first number divided by the second number is less than 0? So we need to get the first number divided by the second number is less than 0. So it has to be a negative number. Okay, so we have 4 numbers here. So when I pick 1 the first time, it's going to be 1 out of 4. And then I put that one back, and then I'm going to pick another one, and it's 1 out of 4. So my total possibilities is 16. So there are 16 different choices. Now, out of those 16 different possibilities, I need to see how many are going to be less than 0. How many negative ones? So I start with this 4 here. 4 divided by a negative is going to be positive. 4 divided by a negative is going to be positive. Negative 4 divided by a positive is going to be a negative. So there's 1. Okay. Now, I'm done with the 4. And I could do 4 divided by negative 4. Negative 4 divided by negative 4 is a positive. So let's be done with that. So now let's go with the 2. 2 divided by 2 is positive. 2 divided by negative 4, that's a negative. I'm going to do tally marks here. I'll cross it out. So the first one, we have a 1. 2 divided by negative 4, that's negative, so there's another one. 2 divided by negative 2, there's another one. 2 divided by negative 1, there's another one. Okay? Now we're done with the 2. Now let's go to the negative 2. Negative 2 divided by negative 2 is a positive. Negative 2 divided by a negative is a positive. Negative 2 divided by a negative is a positive. And the negative 2 divided by 2, that's a negative. So just 1 there. Okay, I'm done with that one. Then this negative is going to be the same as these other 2 negatives, where it's just going to be 1. So 1, 2, 3, 4, 5, 6. 6 out of 16. And I'm going to simplify that to be 3/8. And then I'm going to put that into a percent. It's 37.5%. So the chance of, when I pick 2 different numbers, pick one, put it back, pick another one, and then I divide those 2 together, and I'm going to get a negative number. It's going to happen about 37.5% of the time. All right, last one. So we have theoretical and we have experimental. The theoretical, we're only going to use this spinner to get those. The experimental, we're going to have to use these. Okay? So let's look at if we want to get a 1, what's the theoretical probability? There's 1 there. 1 out of 1, 2, 3, 4, 5, 6, 7, 8. So it's going to be 1/8. 1 out of 8. Or you could say 12.5%. I'll take either. Now let's do number 2. So here's a 2, and here's a 2. 2. 2 out of 8, or 1/4, or 25%. And then we got a 3. 1 3 here. Oh, same thing. There's 2 3s, so it's going to be the same as the number 2, 2 eighths, 1 4th, or 25%. Then we have number 4. Oh, this time we have 1, 2, 3. 3 out of 8, which is going to be 37.5%. Now let's talk about an even number. So we have even numbers are 2 and 4. So we could go, we look at this 2 here and this 4 here. This was 2 out of 8. This is 3 out of 8. So it's going to be 5 out of 8. And when it's 5 divided by 8, it's 62.5%. Now let's look at an odd. That's this one here and this one here, which is 1/8 and 2/8. So that's going to be 3/8 or 37.5%. And then a 1 or a 2. So we have 1/8 and 2/8, so that's going to be 3/8, which is a 37.5%. And then less than 4. Less than 4 would be a 1, a 2, and a 3. So we have 1/8, 2/8, and 2/8, and that gets me 5 out of the 8. And 5 out of 8 is 62.5%. Okay. Now, we got to do the experimental. With the experimental, we need to know how many times we did it. So we have a 4, a 3, a 6, and a 7. So that's 4 plus 3 plus 6 plus 7. So we did a total of 20 times. So experimental to get a 1 was 4 out of 20. 4 out of 20, or 1/5, or 20%. Now, number 2 is this 3. 3 out of 20, or that would be 15%. Then we have number 3, which is 6. 6 out of 20. 6 out of 20, we can reduce that to 3/10, and that gets us 30%. Then number 4 is 7. 7 out of 20. 7 out of 20, which is 35%. Now let's do it even, which is even would be this 3 and this 7. So 10 out of 20. 10 out of 20. Oops. 20, which is 1/2, which is 50%. And then an odd would be the 6 and the 4, which is 10 out of 20, which is 1/2, which is 50%. Now, a 1 or a 2, that would be 7 out of 20, which is the 35%. And then less than 4, which is these 3 together. So that's 4 plus 3 plus 6, and that is 13. 13 out of 20. And 13 out of 20 equals 65%. Okay. Last 2 questions. Is the theoretical probability greater than, less than, or equal to the experimental? So I'm going to look at the theoretical. The theoretical is 1/8. 1/8, or 12.5%. That's in theory what I should get when I spin a 1. Now, what actually happened when I spun a 1 is I got a 1 out of 5, which is a 20%. This is the theoretical. This is the experimental. So the theoretical probability, 12.5, is 12.5 compared to 20%, less than. So in theory, it should have been less than what we actually got. Last question. What do you expect? What would you expect after even more spins? So the experimental, I'm doing the experimental. I'm going to do more and more and more spins. What do you think will happen? Is it going to get closer to the theoretical or farther away from the theoretical? Or will it stay the same? Well, what should happen is it will get closer to the theoretical. So so let's take this 1, for example. Experimentally, I got 4 out of 20. But if I keep doing more and more spins, I bet this 20% gets a lot closer to this 12.5%. That is my prediction. All right. Hopefully that gives you a chance to kind of review all the questions. Test A will be very similar to this one, just with some different numbers involved. You will see that I sent you a blank copy of the test. You can practice test B again and check your work, watch this video, and see how you do. Test will be on Friday. Let me know if you have any questions.